Okay. Open up to 2-2, right around page 72, 73.
Start it. Stop.
I will. Okay. Yes, I am recording this lesson. Okay.
Are you going to put it on the site? Yeah.
Something like that. All right, a couple of things. First of all, yes, I will check your assignments today like usual. All right, but first I want to get through this idea called prime factorization. Okay, I love prime factorization. I think it's a lot of fun. Okay, but in order to kind of use it to our advantage, we need to be able to, because we're going to have to use it a lot this year, we need to kind of start with some basics. Okay, so this is 2-2. And it deals primarily with this idea called prime factorization.
Like prime factorization trees?
Exactly. And if you just read that, or do you actually?
No, we did it last year.
You did these last year? I love these. Okay. Oh, prime factorization tree, prime factorization tree. How lovely are your branches. Shh. 5, 4, 3, 2, 1. Okay, I think we get the idea. So the first thing you need to understand is what's a prime number. Okay, so let's start with that idea. Can anybody explain to me in their own words what they think a prime number is? Dalton. In your own words. Finn.
It's a number that can't be multiplied by anything to make it, except for it's a self and 1.
Okay, not multiplied, but
No, divided.
divided. Okay, so a prime number is a number that has nothing that can go into it evenly. Okay, what do I mean by that? Okay, all right, so let's take 5 for example. Okay, if we were to take and divide 5 by 1, we get a whole number, 5. Okay, but if we take and divide 5 by 2, we get 2.5. That's a decimal. Okay, it doesn't give us a whole number answer. If you take and divide 5 by 3, okay, you will get something like 1.6-ish. Try it. 5 divided by 3, I think it's like 1.6 repeating. Okay. Again, a decimal, not a whole number. 5 divided by 4 is what, 1.25? Okay, and again, it's a decimal. So here's what we're saying. If you take 5 divided by 5, you get 1. Hey, listen, you can sneeze, that's fine, but you don't need to sneeze to that magnitude. And if that's the case, do it outside my classroom. Got it? I was actually, it's one of the not so proud moments of my middle school career. I did that, being a smart aleck, trying for attention, when I was in school, arguing, I just need to sneeze, okay? Which, in all reality, I've actually looked it up. No one actually needs to sneeze that loud or cough that loud. And I was suspended. So,
Suspended?
Yeah, I was suspended because I argued with the assistant principal when I got sent to the office. Okay? So, let's just leave it at this. If you need to cough or sneeze, you don't need to disrupt my class with such a loud, exuberant outpouring of noise. Okay? So, here's what we're getting at. 5 divided by 1 is 5. 5 divided by 5 is 1. Those are whole numbers. Nothing else can go into 5 and give us a whole number. Therefore, 5 is prime. Okay? We're not talking Optimus prime. We're just talking prime. Okay?
Like odd numbers?
Well, pretty much all prime numbers are the following. Pretty much all prime numbers are odd, save 1. Does anyone know what is the only even prime number? Yes?
4.
No? But that's a great guess. 2 can go into 4 evenly. Todd? 0 is neither odd nor even. It is just 0. Mr. Rotz? 2 is correct. All prime numbers are odd except
Wait, I thought 2 was even.
2.
It is.
Wait.
All prime numbers are odd except 2, which is even. Because every even number, what number can go into every even number? Yes, Morgan? Correct. Very good. Yes. Okay. So we know that all prime numbers are odd except 2. And prime numbers start with 1. So 1's prime, 2 is prime, 3 is prime. What about 4?
No.
4 is even. 2 can go into 4. So evenly. So 4 is not. We already proved 5 is. What about 6? No, 6 is not. What goes into 6 evenly? Yeah. 3 does. And what else? Yeah. 2. So 2 and 3 go into 6. What about 7?
No.
Can anything go into 7 evenly?
No.
Okay, so 7 is prime. 8,
No.
it's even. 9,
No.
Yeah.
I mean, yes. 3 can go into 9.
3 can go into 9,
So it's not.
so it's not prime. 3 can go into 9. What about 10?
No, that's not because 5 and 2.
5, 2.
Yeah, 5 and 2.
5 and 2. 11?
No. Oh, wait. That's prime.
11 is prime. Okay, now, what ends up happening as these numbers get larger is there becomes larger gaps between the prime numbers. And the reason is, for instance, 22. 22 is divisible by 11. 11 goes into 22 2 times. Not only that, but 22, or like 33. 11 goes into 33 3 times. And so what ends up happening is that you get a lot of prime numbers here, and then your prime numbers become more rare. Okay, now 13 is prime, but 14, 15, 16 are not. 17 is prime, 18 is not. 19 is, but 20, 21, 22 are not prime. 23 is, 24, 25, 26, 27, 28 are not. 29 is, and etc. And we can keep going. All right, so these are prime numbers. Now, for prime factorization, the goal is to use the numbers in this range. Most every number you're going to use for prime factorization is going to fall in like the first 1 to 30 prime numbers. Okay? By that I mean from number 1 to number 30, most of the numbers you're going to look at are going to use either 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, etc. Yes?
Hey, for our past homework assignment, you never really let us check our...
Not yet. I will. I will. Okay. So, here's what we're going to do. How do we start with a prime factorization tree? Do we start with a prime number, or do we start with a number that's not prime? Maya, you want to give it a guess? Yeah, we start with a number that's not prime. So let's start with something between 50 and 100. Someone give me a number between 50 and 100 that is not prime. Cade.
60.
All right, 60. Okay, so let's start with 60. When you're doing a prime factorization tree, you want to give yourself lots of room on both sides. Okay, so I'll put 60 right in the middle. And the very first thing I do is I try to come up with 2 branches for my tree. 2 things that when multiplied together give me 60. Okay, so Jackson, what do you got?
30 and 2.
All right, 2 and 30. I really like putting the smaller number first and the larger number second, because we normally read multiplication from left to right. To be honest with you, it doesn't matter. Okay, but it's fine. Now, stop. When you get to the first new set of branches, okay, these are called factors, okay, prime factorization tree, that's what these are. These are called factors. You have to ask yourself, are any of my factors prime on this first level of my tree? And are any of them prime, Finn?
Yeah.
Which one's prime? 2 is. When you get to a prime number, circle it. Now you know not to mess with that number anymore. Okay? This one's done. This branch of the tree no longer needs attention. But 30 still needs attention. So now we go on to the second level of our prime factorization tree. We need to come up with two numbers that when multiplied together give us 30. Mr. Rotz? 2 and 15. So 2 and 15. Now, Mr. Rotz, are any of these factors prime?
Yes.
Which one?
2.
2 is. Circle it. I'm not going to touch that one anymore. Is 15? Can anything go into 15 evenly? Jayla? Oh, you got this. What can go into 15? Give me. Yeah. Fantastic. See? Awesome work. All right. So, we've got 15, 3, and 5. Okay? Now, the question is, are either of these factors prime? Todd? They both are. So we circle them both. Now, stop. If all of my factors get to a point where they're all circled, I'm done. Okay? So then I have to rewrite it. And here's how we do that. We pull all the factors out and we just multiply them by each other. All of the prime factors. Get the whole prime factorization thing going on here? So, 2, check, times 2, check, times 3, check, times 5.
Check times 5.
Check. That is a prime factorization for 60. Okay?
How many of these do we have to do?
We'll do lots of these this year.
We got 126.
Now, the next thing that we should have to do is we need to simplify it. Yesterday, I said when you have numbers that are the same and you multiply them, you can write them with a what? Why did we do that yesterday? Yeah. Yeah, an exponent, right? An exponent. So I have 2 times 2. How else can I write that? Yeah. 2 raised to the... Oh, come on, you got it.
Second power.
Yeah, 2 squared. So I'm going to rewrite that. 2 times 2 as 2 squared times 3 times 5. That, ladies and gentlemen, is the prime factorization for 60. No other number has this same prime factorization. Just 60.
That is unique.
Okay? The benefit of this is that later on it's going to help us a lot with simplifying fractions. Okay? Especially with fractions that have massive, like 6, 7 digits in them. Okay?
7-digit fraction?
Yeah, man. What's up, Finn?
Wasn't there like a ladder?
A ladder?
Ladder. Like the greatest common multiple and the least common.
Oh, let's not go there yet.
No, there was like a ladder where you could do.
All right, let's do another example. Give me a number between 100 and 200 that's not prime. Mr. Biebrick? 150. All right, let's do 150.
150.
Now, I will give you another hint about solving these. Okay? If you use 2 for even numbers, you're always going to have one side of your prime factorization that's really long. Okay? Like over here, it went really long in this direction. But if you can come up with something other than 2 right away, it really helps. So something even like 3, 5, 7, 11, etc. So, Landon, do you have a number not 2 that we could use to come up with to start this process? Yeah. 30 times 5. That's great. Okay, so let's start with that. 5 over here times 30. Are either of these prime? By the way, they don't have to be. You can run with 2 sides of your tree. You don't always end up with a prime in every breakdown. Okay? So for instance, if I had 25 and 6, that would have been an option here. 25 and 6, I would have had to have done 2 sides. Okay? Because 6 is not prime and 25 is not prime. But in this particular case, one of them is prime, and it is 5. So I'm going to circle 5, and now I'm done with 5 for right now. Move my attention to 30. Okay, so 30. How can I break 30 down? Yeah.
I have a question.
That's great. 30. Amaya? Yeah, 5 and 6. I like that one. Okay. Are any of those prime? Madeline? Yeah, 5 is prime. So 5, circle it, done. 6.
Whoa.
Yeah, man. 2 and 3, bring them back the doses and the traces. The doses and the traces. 2 and 3. Either one of those prime?
Yeah,
Both.
Yeah. I did it differently and still got the same answer.
Can you just
Okay, now, this particular problem, we have the 5s that came out first, the 2s and the 3s at the end. So what we do is we always write them in numerical order. So 2 comes first, then we multiply it, check, by 3, check, then 5, and it doesn't matter which one I do first, by 5. All right, I've accounted for all my prime numbers, but I still need to do the final step of consolidating, adding together, introducing that exponent notation. Amaya, you did a great job last time. What am I going to do?
2 times 3 times 5 squared.
Excellent. Times 5 squared. That's fantastic. It's fantastic. And that is the answer.
What if you just found 2 prime numbers right off the bat?
Okay, give me an example. What do you think would be an example of that?
10.
10. Perfect. 10, 2, and 5. Hey, I'm done. 2, 5. So we write it as 2 times 5. That is the prime factorization for 10. Yeah. You know what? You can go straight to the exponent notation. That would be fine. Yep. All right, so on your homework tonight, you're going to be asked to do a lot of prime factorization. So I'm going to give you some time here as I call you up to turn in yesterday's assignment and check it. You guys are going to have about 25 minutes. But before you go, before I put the assignment up, listen carefully. The prime factorization trees are going to be the sole thing I'm pretty much looking for on your next homework quiz. So I need you to show all your work, which is why I'm giving you so much time today. Does anyone have any questions?
No.
Okay. Then, here's your assignment for tonight. Did I hear a question? Every single one of what? Assignments? Oh, prime factorization? No. I can do prime numbers up to a certain ways, but sometimes, I mean, once you get into like the couple thousands or whatever, it gets tough.
Like on the thousands?
Yeah.
You can go all the way up to the thousands.
Okay. Page 77. Numbers 1 through 7 all. 18 to 32, the evens. Any questions? All right, you may begin. And I'm going to go ahead and stop this recording.